In this video, we're going to talk about some basic terminology of angles, and we're also going to talk about how to sketch the graph of an angle in standard position. Now, to start off with, first we're going to talk about what a ray is. A ray is where you have an endpoint, your starting point, and then a ray comes out into a specific direction that's defined by another point, F. Now, the order is important in which we write EF. If I say ray EF, that means I start here at E and I come out to F, drawing an arrow indicating that it goes on in that direction of F. If I wrote ray FE, then that means I would start at point F and draw my arrow out in the direction of E. A ray only should be going in one direction. You should not have arrows pointing in both directions. Okay, so we start for ray FE, I start at F, which is our endpoint, and then we come out in the direction of E. To draw an angle is made up of two rays. Here's one ray. That's ray ED, because I come out from E to D. And then I have ray EF, because I come out from E in the direction of F. And that forms an angle right here. And the point in which those two rays come together is called the vertex. And again, the way we label our angle is important. If I say this is angle DEF, when I go to draw it, if this is D, this is E, and this is F, if I label this as angle DEF, that means I start at D, I go to E, and I go to F. That would be this angle here. Now, if I wrote it in another way, let's say I have, here's the point E, here's the point D, here's the point F. Let's say I wrote it as angle, let's see, DFE. That's going to be different than this angle, DEF, because I'm going to start with D, I'm going to say DFE. So that's going to be this angle here. So this center variable or letter, however you label it, is going to be where the two rays come together for your vertex. The notation that we use to show that something is an angle looks like this. It's literally a little angle, and then we label what angle that is. This is called theta, and we use that a lot for angles. But I could also draw another angle and call it something else. Let's say I call it alpha. So this angle here, I would write down, the notation would be angle alpha. Or I don't have to use Greek letters. Maybe I want to label it as angle A. So if this angle here is A, then I would write it as angle A. So just our notation for how we write down our angle. Now, when we form our angle, we start with an initial side. And then what we do is we sweep open, and depending on how big we want our angle to be, the wider we want our angle to be, the further out this comes here. Where we stop, that side is called the terminal side. So this is my initial side. It sweeps open, and where it stops, that's the ray is called, that ray is called the terminal side. And again, of course, where they come together is called your vertex. If we want an angle in standard position, the initial side needs to be on the positive x-axis. So on this side of the x-axis. And then when we sweep it open from there, that creates our terminal side. So in order for something to be in standard position, the initial side has to start on the positive x-axis and sweep open. Oh, actually, let me mention something this also. If it sweeps open this way, this is going to be a positive angle. If it starts here on the initial side, but it sweeps open this way, this would be a negative angle. So the positive and negative in front of whatever your degrees is for your angle just tells you which direction that terminal side sweeps open. Okay, some basic angles. If your initial side starts on the positive x-axis and it opens to the positive y-axis, that's a 90-degree angle that's in standard position. And a lot of times you'll see a little box here. If it's not written in 90 degrees, but you see a little box here, that's the notation for assuming that that's 90 degrees. Now you can have a 90-degree angle somewhere else. So I could have a 90-degree angle right here. That's 90 degrees, but that's not in an initial position. The initial position is that's not in standard position. The standard position would be if it starts here on the positive x-axis and opens up in the other direction. Okay, then you have 180 degrees. If it's in standard position, you start here on the positive x-axis, and 180 degrees would be twice that of 90, so it would open, so it would open all the way up this way. So it would look like a straight line with arrows going in either direction. I would have one ray pointing this way, one ray pointing this way. So this would be 180 degrees. If I opened it in the other direction, instead of opening it up this way, if I started here and opened it up in this direction, that would be negative 180 degrees. And the negative only tells us which directions it's opened. All right, now another important angle that we'll use a lot is 270. So if we want it in standard position, we start it here on the positive x-axis. From here to here is 90, then from here to here is 180, and then if I go another 90 degrees this way, then that would be 270 degrees. Okay, then if I sweep it all the way around and I make one full complete cycle. So if I start in standard position, my initial side is on the positive x-axis, and I do one complete rotation, and my initial side and my terminal side lands right on top of my initial side, then that's going to be 360 degrees. I could also have 0 degrees. If I start here with my initial side, but I don't sweep open at all. So my initial side and my terminal side lie right on top of each other, but I don't have any sweeping. It doesn't sweep open at all. That would be 0 degrees. So your 0 degree angle and your 360 degree angle both look the same because their terminal and initial side is laying right on top of each other. But the difference is that with the 360, it actually opened up one full cycle, where with this one, it didn't open at all. Okay, and here's everything labeled for you that I just went through. These are called your quadrantal angles, okay? That's angles that have a terminal side that lies along an axis. And here's all the ones I just went through with you. The additional information that's on this picture is it also labels your quadrants. So your quadrants, when you're looking at a grid, your first quadrant is always the upper right-hand corner. And then it goes around counterclockwise. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. When you're in quadrant 1, your x coordinate is positive and your y coordinate is positive. When you're in quadrant 2, your x is negative and your y is positive. When you're in quadrant 3, your x is negative and your y is negative. And then when you're in quadrant 4, your x is positive and your y is negative. Okay, so we're going to do 2 examples of how to draw angles in standard position. So the first example is we're going to draw angle of 30 degrees in standard position. All right, now because I know that if I start here on my initial side of my positive x-axis, that's in standard position, and I sweep open to my positive y-axis, I know that would give me 90 degrees. So I know 30 degrees has got to be in the first quadrant. It can't be in the second quadrant because that would be bigger. If I swept even further open, that would be bigger than 90 degrees. So I know 30 degrees has got to be in this first quadrant somewhere. Now, if I take 30 degrees out of 90 degrees, that's a third. So that's a third of this big angle right here, 90 degrees. So if I break this up into 3 pieces, if I sweep this out from here to here, that would be 30 degrees. If I sweep this out from here to here, that would be 60 degrees. And then if I sweep out completely, there's my 90 degrees. So I know my 30 degrees has got to be somewhere here in my first quadrant. And it's roughly, I can just draw a rough sketch, kind of visualizing and using my intuition and my knowledge of fractions, knowing that 30 is a third of 90, so it's probably somewhere in here. Now, if I wanted to sketch 45 degrees in standard position, I know 45 is half of 90. So if from here to here is 90, I know somewhere in here would be 45 degrees. So I would start here, here's my initial side, and I would swing open to about halfway between, or estimate, because this isn't, we're not counting squares or anything on graph paper, but this would be about 45 if I go halfway between 0 and 90 degrees. For negative angles, I know I have to go in the other direction. So I start here. That's my initial side. I want to draw negative 135 degrees in standard position. Okay, so I start here. I know if I sweep out from here to here, that's a quadrant, one full quadrant, that would be 90 degrees, but going in the negative direction. So from here to here would be 90 degrees. I know from here to here, if I go all the way this way, 2 quadrants, if I sweep out 2 quadrants, I know that's 180. And going in this direction here, I know that that would be negative 180 degrees. So I know negative 135 has got to fall somewhere here in the third quadrant. And so if I know that it's going to be halfway between here and here, because if I take 90 degrees and I add 45, that's 135 degrees. So I know from here to here is 90, and then I do another 45, which would be halfway from here to here, which would be our 90. Okay, so this would be, from here to here, would be our negative 135.